Hello everyone, I'm introducing my capstone projects for Google Intensive AI course. Actually, my project is about creating a simple rack system using ChromaDB and LangGraph and Gemini. Uh, so basically, the idea was about to help people that doesn't have a lot of experience with cars, um, or doesn't know how to read repair manuals, to help them actually diagnose what is going on wrong with their cars. So we will basically, the idea is we're gonna go grab one of these free manuals, and then we're gonna go read that manual, index it inside, index it and create embedded in the ChromaDB. And then on the top of that, we're gonna use create some long graph with multiple nodes that will guide the user through that through that process to find the right answer. So without any further ado, let's go actually straight. So here you will see at the beginning, I'm just removing some of that conflicting packages in here at the top, and then I'm installing all the packages I need. I need Google AI, Gen, some PDF packages because we're gonna read some the PDF files. Then you see here that we actually run a Gen AI, Google Gen AI version 1.11. You go to Google AI Studio and create your API key. And here I'm just listing all the embedded models that are currently offered by Gen AI from Google. And here is just a simple class that basically is be responsible of extracting all the text from this PDF, extracting all the images from the PDF, and then embed this inside our vector database. So you will see all start from here, which is process PDF. All right, so we go through the process PDF, you read the file, and then you read PDF in here. All right, you will just read the PDF and then extract some metadata about that document, and then check if there is an extracted text, and if there is extract image flag is on, we try to see if there is any images, and then we add it in, and then we add the metadata. And at the end, after we read all that PDF, we will go ahead and store it inside the Chroma database. So that's how we actually store it here. Be mindful when you try to run this step, because it's just going to take some time, because that manual has about 1283 pages, so it's just going to take sometimes run from 5 to 10 minutes. So as you can see, that's how many documents we have. Here is a peek of the first embedded for the first document. Then let's say we now, since we already embedded this, let's ask him a very simple question like, what is the ideal pressure for a tire? I'll just make sure you set the embedded function document mode to false, just to tell the model that you want to embed it, each piece of the text you try to query in your query. You will see here is actually the answers here. We just get the first or the top first answer, which is the closest answer to or segment to the query we provided. And you see here in between there is actually an answer here for what is the ideal pressure, which is gonna run about minus 29 psi for that model. So all right, as you can see, these not a very useful answers. So we're gonna try to incorporate Gemini to make this answer more naturally, uh, like and easy to understand, and user friendly. So here we just have a very simple prompt that we're gonna wrap that uh, we'll wrap our query actually that we provided earlier, and then we pass the whole thing back the um, to the LLM. As you can see, the Gemini 2.0 Flash is trimmed this and answered very precisely by saying, um, according to the passage, you should check your tires for wear and tear and make sure they have the proper inflation pressure for the size, blah blah blah, and then the correct tire inflation pressure is 200 kb, which is equivalent to 29 psi. Awesome. That's great. But can we do better? Can we do better? Can we have a full-fledged system? Yes, we can. So, so starting setting up the system, I just need to set up some prompt here up front, and that's I'm gonna come to it later. But as you can see here, we just set up the graph status for our agent, and we will just have a track of the messages, the query the user provide, the quality of the response for our rack system has been finished or not, and then there is a new query introduced and the actual response. All right, so here we just setting up the API key and provide it to Longshan library. Then to use this to create our LLM, that will be basically our brain. That's what brain that will when you read the data will ingest the data from that node and decide what it needs to go next. So ours is very simple actually. Uh, Here is how we set it up. We have a chatbot node. We have LLM augment node, which is gonna augment to what has been found in that vector database, as before we have done in above here. So and then we have a couple transition nodes. One first is after we done the augmentation of the response, we need to check the quality. Is it really a good quality or not? So it's just basically it just check if it's sufficient response or insufficient response. And after that, we go to the next step, which is try to find a video explain if we can. Um, how to solve this problem. Um, and then if that's assuming that previous step, we evaluate the LM response as sufficient. But if we did not evaluate this, then we're gonna start actually looking online for us for an answer for our user query. And after that we will respond back with the showing the response back to the user. So here is as we set these nodes, and we have these couple of the conditional edges between these nodes, and you see after we set them up, you're gonna go to chatbot. You don't have any, still is a brand new, then you're gonna print out the welcome message, and then goes back in here, which is just gonna run our vector query against the embedded database, and then we're gonna pass this to the limb augmented step, and then after that, after we get the response from the LLM, we checking the quality, and if the quality good, we try to look for in a video, and if we find a video, we will respond back to the user. But if we could not, if the quality was not that good, we're gonna go out online and search using LLM equipped with some Google search tool, and then after searching the internet, we're gonna respond going back to the video node, try to find any video explaining what we have been that whole answers or response. All right. So where we stopped, we said that we now um, we're gonna respond and shows the response at the end and print it out. So here we start our invoking our chat graph, and we're just gonna start and we're gonna ask the same exact question we asked before. What is the ideal pressure for the tire? But this time, instead of getting the answer, you just got the a full, actually detailed answer that it here it says upon inspection. You should find that tire pressure is 29 psi, but it tell you how to uh, it's more verbose actually and more data included, and even at the end you'll find that we find a YouTube video that is actually uh, allow you or explain to you how you can find the pressure for a tire, in the Toyota Camry, which basically that was the document we trained on, or we embedded in our vector database. It was about 2002 Toyota Camry. So and here, so if we printed all the messages that was back and forth between passing down between these nodes, you will see here is like a start. By the welcome message. It went and asked. It got that passage that from the vector database. Then try to get an answer online or augmented that. Find the answer is sufficient. Then it went to the last step, which is try to find a YouTube video that explained this, and then it ran down and put all these answers. Okay, that's great. What about if I ask a question that does not exist in the database in the first place? Question like this: why is my engine making a knocking sound? It's simple. We had a step here where it says if we could not find a sufficient answer, and we should go straight to SKLM to use a Google search as a tool, and then try to find the answer for us. But that depends on making these quality notes actually determine and says, oh, this answer is insufficient. And that's indeed what happened in here when we ask this very open question, which is like open-ended question: why is my engine making a knocking sound? Uh, it's respond and it says, okay, there is a potential causes for an engine to have knocking in 2002 Toyota Camry. Let's focus in this specific model in here, and this is the good thing is actually start looking at the common problem in this model and in that specific year, and it tell you what is it could be, and it just start showing this, and it gives you some diagnosis and things to do. Not just that, it actually put you some citation from from where they got this information, and at the end also got you a YouTube video that it's while in here you can see is actually it it show you how is some noise, like some noises that are coming from that specific engine, and how that actually that guy able to solve it and demonstrate that he was able to determine this the issue was from the timing chain tensor, um, and that's what show you here how to replace it. As we showed before, he uses the back and forth between and the state that been going through passing down three different nodes, and how actually our LLM concluded this answer. With this notebook, actually, I also have um, and we will have this written in a blog post soon, and I will include the link in this notebook. Thank you. See you later.